Hey folks, how are you? Azure Cosmos
Hey,
DB Live TV. I'm your host, Mark Brown. This is our special Build 2023 Roundup episode, and I've got a whole bunch of my team here with me this week. Build was back, and not just in that really lame virtual sense. It was actual real people getting together, going to real sessions and real demos and real discussions and real labs and just everybody doing what everybody should be doing at big events like Build. So we had a lot of great stuff we announced last week and showed off, and we're here to give you a recap of all that. So where'd all my team go? Oh, there they are. I like it. It's like Brady Bunch. We need more folks here. And then we need Alice to kind of pop out right through the middle, right at the end. There's kind of the payoff. So all right, let's. Good to see you all here, and we're going to go through kind of all the big stuff we announced last week. So if you missed anything, this is the show for you this week. So right on. Let's start with Justine. Hey, how are you?
hey, Mark. I'm doing good. How are you?
I'm doing
I'm
fantastic. I'm excited. Oh wait, there you go. Wow, it's like a boomerang. You had wow, we had some major announcements this week. The first one I'm super excited by, but the other ones I am too. So let's talk about all these. First up, we announced a gated preview for something that I think customers have been waiting for like almost 5 years. I think we've been talking about this. We've had various names for it. It's now called change feed all versions and deletes, and we've got a new preview of this gated preview, so people can sign up. You want to talk to us kind of a little bit about what we announced last week?
Yeah, definitely. So, yes, a lot of very exciting announcements, some of which have been extremely long awaited. The first one is change feed. So, we announced change feed modes. The change feed that you know and love now is even better with a new mode called all versions and deletes. So, this allows you to get changes not only from your create and your update operations, but also from your delete operations. And so, whenever there's a delete, either through an explicit delete of an item or a TTL expiration, you'll actually get a change in your change feed if you are reading in all versions and deletes mode. So, as Mark mentioned, this is a gated preview. So, you do have to sign up, and you can sign up through the Preview Features Blade in the Azure portal. This will be enabled on your account, and it will allow you to use the same methods of change feed that you know and love, the change feed processor, the pull model, but you'll be able to use them with a new mode. So I actually have a demo. I will show you guys how easy this is to set up and some of the cool features that you'll be able to get. So
Cool.
this is an example using the .NET SDK with the pull model. And you can see I'm creating my change feed iterator here, and I'm passing in two things. So I'm going to tell the change feed when I want to start reading my changes from. With all versions and deletes mode, you can either read from now or from a previous lease or continuation. And the next thing I pass in is my change feed mode. So I'm telling change feed, hey, go ahead and read this in all versions and deletes mode. So I'm going to go ahead and start this demo, and it will do a couple of things. So first, we're going to set up our container reference, make sure that we're creating our change feed iterator, and then I'm going to start ingesting some data. So I want to have some changes that we can go ahead and process. And this is just doing create and update operations on random number IDs. We'll go ahead and add some delete operations too. So again, just randomly deleting a couple of documents. And now I'm going to actually go ahead and read the feed. So you can see all of those changes that we just made coming through. And I'm going to scroll up. We have a couple of really awesome improvements. So not only do I get my creates and my replaces, I also get metadata that tells me what type of operation this was. Previously, you just get an item. You don't really know if it was a create or update or what the operation was. And you can see that we also have deletes captured here. So all of those documents that were deleted are automatically given to me with the change feed.
So can I? This is cool. I didn't realize, and I haven't played with it, so this is my fault. That it's a mode you set in here with change feed mode. So when I set change feed mode, are there other modes that I can set in here using this?
Yeah, great question. So the old previous version of ChangeFeed is still available. We renamed it to latest version. And the reason is with the, old ChangeFeed and latest version mode, you get the latest version of the document. So you might not get every single change that happened, but you'll get the latest state. With all versions and deletes mode, you actually do get every single change. So if I update the document once and then I update it again and then read the feed, I'll be able to see both of those distinct updates.
When I get a change coming in, let's just say I update something, do I get to see the previous version of that as well when it comes in?
That is going to be added in the near future. We don't quite show you the previous version on updates, but for delete operations, you will see the data model changed a little bit, and you can read more about it in the docs, but you will see like the previous version from a delete, which is just the item that was deleted.
Got it. Yeah, that's great. I know people are really excited about being able
Yeah.
to flow deletes through, right? Like I regularly get beat up on Twitter about having to use tombstone flags in their data. But hey, it is a database. You should never really delete data anyway, but they still give me a hard time about it. So this is pretty exciting. I'm really, like I said, customers have been waiting for us to do this for a really long time. I'm just ecstatic that we're giving this to them. So this is great. We've got a link here below. What can they see? Can they sign up for the preview here from the link that we've got?
Yeah, so this link will point you to a blog post that will tell you all of the information about this version, all versions and deletes, this mode and the previous mode. It'll help you understand, when to use which mode. Just because you sign up for our preview does not mean that you have to exclusively use all versions and deletes. You can still use latest version. There are very valid use cases for both modes, and it will show you how to sign up.
Okay, and I'm guessing SDK update required, correct?
Yes, so you'll have to be using the preview version of our SDK. There's the change feed processor available in Java or the pull model in .NET and Java.
Okay, cool. What's next?
Yeah, so one other thing that we released is increased integration with OpenTelemetry and application insights. So OpenTelemetry is a vendor-neutral set of APIs and SDKs that allow you to instrument your telemetry data from your application and really learn more about what's going on under the hood. So actually, in this exact same change feed demo that I had just shown you, if I scroll up a little bit, we can see where I configured OpenTelemetry for this application. And you can see this is just boilerplate OpenTelemetry code, so it has nothing to do with Cosmos DB specifically. I can set up a logger factory and choose where to export my logs to. So I'm going to export my logs to Azure Monitor and via Application Insights. And then I set up my trace provider. I configure the source to be for Cosmos DB. And again, I give my exporter for my traces. So what this does is it allows you to, regardless of mode, if you're using gateway mode or direct mode for connectivity in your application, if you configure OpenTelemetry, you will be able to get logs, what happened on your operations, as well as diagnostic logs for high latency requests. And you'll be able to see that in whatever exporter you configure. I can show you really quickly what this looks like in OpenTelemetry in Application Insights. So I have my Application Insights instance here, and you can see my application is making requests to my Azure Cosmos DB account. And you can do all sorts of things that you can do in Application Insights, but now we have our Cosmos DB data delivered here for you. So you can do things like investigate performance. I can see, for the different types of operations I had, what did my requests look like? I can drill into samples, and I can see all sorts of metadata that will help me better debug these transactions. I can see, what operation type it was. I can see my connection mode. If it was direct mode, you'll get the status code, you'll get request charge. So everything that you need to help you debug applications, we've made it really easy for you just by setting up OpenTelemetry. You don't have to specifically instrument each request, but it all just sort of happens automatically.
Yeah, this is great. And I love that we've got support for direct TCP mode. I knew that was a blocker for a while. We could only do it, or the app itself could only do it over HTTPS. So that's great. They're able to hook into our transport layer on this.
Yeah.
Looks great. Love it. Last up, you had another one. You had a busy build, didn't you?
Yes, very busy. Yeah. So the last feature that we are really excited to talk about is called computed properties. So this is in the query space. It basically allows you to define properties in your container that are not necessarily persisted in items themselves, but actually have values that are derived from other properties. And what that ends up looking like is a query over a property. So I'll show one last demo. of defining some of these computer properties. So I have this sample application, and I'm going to define a couple computer properties on my container. I will give it a name and a value, which is determined based on a query. So let's take this example for month updated. Now, this container just has a really simple product catalog. Let's say I want to get the month out of my timestamp value. So we can see c.ts. This is the, good old _ts that is in every single Cosmos DB document. But let's say I wanted to get the month out of it. This is a little bit complex. There's two system functions that are being combined here. Datetime part can't actually use the index. So this would be really expensive. It would be a full scan. And every time I want to use this before computed property, I would have to write this clunky thing potentially multiple times. With computed properties, it allows you to write this complex logic one time and use it multiple times in your actual queries. So say you want to filter on the month and then also group by month or something like that. This will really make it easier for you. And it will also give performance benefits because these properties can actually be indexed. So this is where the real value of computer properties comes in. And I'll show you with an example using this month updated property. So I've already created a computer property on my container. Now I can actually order by this computer property. This is such a big deal because previously you could only order by properties that actually existed in your document. So you would never be able to do something like the query above where you're ordering by a system function. This is really a huge improvement. Now you can order by any complex logic you want just by defining a computer property on your container.
Wow, this is super. I'm now thinking about all the demos I have to rewrite because
Yeah,
of
it's
this
a big
feature.
improvement. And it's not
This is
just order
another
by,
big one for us. Yep.
Yeah, adding the ability to index these, you can really improve any system function usage. A lot of them don't use the index very well. And so you might have a full scan. This really gives you RU improvements and also perf improvements for almost any query that uses complex logic or a system function.
That's awesome. Quick question, since I'm the resource provider PM, can I define these things through ARM templates and Bicep?
Yeah, great question. So this is really just an update to your container properties. So anywhere that you can update container properties, you can define these. Currently, we've added support for the .NET SDK. We're working on adding support for Java SDK in the very near future, and we're even going to add support directly in the portal.
Okay, fantastic. A question from a viewer here. I think he's asking about change feed, all versions and deletes. Any ETA and kind of some of the limitations we've got there are going to be removed, like private endpoints. Can we get that? I guess it's not working yet, or?
Yeah, great question.
Yeah,
So
there's the question there.
Yeah, there is a limitation on private endpoints today. We are working hard to remove this. We expect to be able to remove the limitation in the next couple of months, but I don't have a firm ETA to share.
Okay. Yeah. Right. And that's the point. We're doing a gated preview. The idea is come use it and give us feedback on this because we want to get the quality bar up as high as possible here. Another question. This is on computed properties here. How do computed properties affect RUs? Seems like it'd have a big impact.
Yeah, great question. So if you index your computed property, then the RU impact for using it in your query will be just like using any other property that had been indexed. So the RU will just be however many RUs it takes to read that value from the index. If you don't index the computed, oh yeah, go ahead.
No, I'm just going to say, but the actual generation and storage of that takes some compute power in there. Is there any RU cost for actually doing the computing itself?
Yeah, so there's no RUs cost to define the property, but every time your computed property is defined for every new write, so an insert or update, it will actually go ahead and update the index. If you chose to index it, then it will update the index in real time, just like all of your other indexes.
Okay.
So if it's not indexed, then there will be no RU impact.
All right. So basically the marginal cost is the indexing of a new property.
Yeah, exactly.
That sounds awesome. And obviously the massive benefits on the read side here. So yeah, everybody should be using this. I love it. It seems like this really fills a huge gap for folks that are trying to do kind of complex bits and pieces with things that might require a full scan with a lot of the system property or system functions, stuff like that. Okay, that's awesome. Thanks, Justine. Next up, Rodrigo. How are you, sir?
I'm fine. How are you, Mark?
I'm really good. You did something also really super exciting, and another one that we've internally talked about for a long time, and this is doing time travel queries with our
Yes.
Synapse link. This is I remember back way back in the day, we were discussing this scenario of doing these, enabling these time travel queries with our analytical store, and now here we are. We got. I'm guessing this is in public preview.
Yes, it's in public preview.
Great.
So
All right. Well, go ahead.
how can I share my slides?
Jay, you want to knock it in there? There we go.
Oh, yeah, there we go. Hold on. So let me go back to the start. So let's talk about time travel with Azure Synapse Link for Cosmos DB. So this new feature for Azure Synapse Link can be used with the NoSQL or with the MongoDB APIs. And it's in public preview. And for now, it's supported with our Spark connector in Synapse Spark, or if you are Databricks customers, with Databricks. And now customers can analyze documents as they were at any point in time in the past with millisecond precision, right? And this capability is important for customers willing to analyze what was updated, what was deleted, and customers can analyze trends within their applications, and most importantly, compare difference between the same document at 2 points in time, right? So it was based on many customers asking for this feature, and now it's in public preview. And how it works? So it's part of our Spark connector, and you can define if you want to start at any specific timestamp, again, millisecond precision, right? Or you can start your time travel specifying another timestamp, because the first option is for the current timestamp or any one, so the second option for any other timestamp. You can also choose if you want to see TTL deletes or user deletes. So it's up for the customer to decide if they want to travel in time through these kinds of operations, right? And also we have an option to analyze intermediate updates, right? And so how it works, I don't know if you can see this image, but basically what we are doing is showing how the syntax works in our Spark connector. Of course, you can use Scala, Python, and with that, you'll be able to see for each document multiple answers for all changes that document had in history since the timestamp you are analyzing from, right? So these are the key links for this new feature, right? So we have these two AKMS links that are important for customers willing to use Synapse Link. And that's it. That's our new time travel capability.
Yeah, pretty awesome. Maybe people don't realize the capability you got here. This is pretty mind-blowing. Just some quick questions. Any limit on how far I can go back?
So the limit is your TTL in analytical store.
Okay.
Right. So that's basically the limit. If you have infinite retention analytical store, you can travel back to any point in time since the beginning of the container.
Okay. Got another question from a viewer here. Is time travel similar to event sourcing with the ability to replay events?
To replay events in analytical store, using Synapse Link, we suggest our also brand new feature, CDC. It was
CDC, right? Yeah, exactly.
Right. So it was released a couple of weeks before build. So both features are based on the same technology, on the same source, but with different approach, right? Time travel is more indicated for a data engineer, data scientist, or maybe an application running Spark jobs to understand what happened. And the CDC is this capability to replay the transactions somewhere else.
Yep. That's awesome, Rodrigo. Super excited. Congratulations on yet another just awesome feature for our analytical store there. So,
Yeah.
okay. Wait. Another question. Do I need to enable time travel to try it? I don't see it as an option under Features tab.
No, it's already there. You just need to use our Spark
Just
connector.
need to use the syntax in that, all baked into the connector, all baked into the Spark. Okay.
Yeah, maybe because we have updated our connector in Synapse Spark base image. So if you have an old image, maybe you have to update your package or maybe create a new cluster. It's up to you. That's it.
Yeah, I figured there's an SDK update required for doing these queries. Right?
Basically, it's an SDK update, so you can use Synapse workspace capability to update packages or create a new version of your cluster, and the new connector will be there.
Got it. Right on. Hey, Rodrigo, thank you very much. More awesomeness. Now, let's go to Tara. Hi, Tara. How are you?
Hey, Mark. How's it going?
Awesome. Super excited. Super tired, actually, after last week. But that's all good. Here's a couple features I talked about last week in the AKS and Cosmos session that we did. We announced GA for hierarchical partition keys, which I think is just mind-blowing, this capability and what we're able to do with our elasticity features in there. Let's talk a little bit about some of the stuff that we did for our elasticity features, including this at Build last week.
Yeah, of course. So we basically have 3 new elasticity features for better cost and performance. And today I'll be highlighting all 3 of them. So we'll start with burst capacity. So burst capacity is now generally available and basically allows users to take full advantage of their database or container's idle throughput capacity to handle spikes of traffic. So for all my visual learners out there, we can take a look at this graph where the user basically is an auto-scale users, and you can tell that at certain downtime periods of their workload, they are building up RUs that they can use to burst up to if they need that. So here you can see that the user is actually able to go over the 1,000 because of the bursts that they collected during their idle time periods. So this is a great feature that has been in public preview for a while, and now that it's GA'd, users can enable it and try it out for themselves. And you can also see in our metrics pane in the portal, you can split by capacity type for your burst capacity settings and see just how much RUs were collected during that short period. So a great way to monitor this feature as well, and you can go ahead and toggle the on the features pane in the portal to turn burst capacity on. So that's burst capacity. Go ahead and give it a try if you haven't already. Again, this is allowing your physical partitions to accumulate up to 5 minutes of idle capacity, and this can be consumed at a rate up to 3,000 RUs.
I don't need an SDK update. I just basically enable the feature and I'm good to go, right?
That should be correct, yeah. And then just note that the only collections that can run this are collections that have less than 3,000 RUs for each container partitions.
Oh, okay. So it's just for small containers. So you have to have less than 3,000 RU for the container?
Or it only affects your partitions that are less than 3,000 RUs.
Got it. Okay.
Yeah.
All right. Well, people should just enable this and just have it all the time, don't you think?
Yeah.
I can't see a reason why you would not put this on.
Yeah, right. Let us know your feedback. We're definitely thinking of potentially defaulting this for users. So would love to get some feedback from our users, our early GA users, to see if that's something that we should investigate.
Cool. Is that link that we've got on the screen now, that'll take them to the blog post? Is there a way they can get and provide us feedback through the blog post you're showing us here?
You can go ahead and comment your feedback directly on the blog post. We also have internal documentations or feel free to reach out on us or on Twitter or on any of the other socials.
I'm on Twitter. Go ahead, just at me right on Twitter. We'll make sure Tara and the folks get it. So cool. Next up, let's talk about hierarchical partition keys. That's what I kind of led with because I'm so excited. But that was another one of our great features that we also went GA with this last week. Let's learn more about that.
Yeah, hierarchical partition keys are also GA'd now, and this feature has been in preview for quite some time, since 2021. Very useful if you are currently using synthetic partition keys, and also very useful if you are a multi-tenant application. So if you want your workload to scale higher than it is right now, then hierarchical partition keys is a great choice for your workload. So with this feature, you can now use up to 3 keys to further subpartition your data, and this enables more optimal data distribution and higher scale. So in this blog post, suppose we have a multi-tenant application that keeps track of user login information with 1,000 tenants, and so each of these tenants also has 10 to 100,000 users. And so right now, without hierarchical partition keys, each single tenant would be capped at the 20 GB of data, but with hierarchical partition keys, it actually allows them to exceed that limit. So for writing and reading operations, this is much more optimal while using hierarchical partition keys rather than our current single partition keys. And to add hierarchical partition keys in the past, you could only do this using the SDK and not through the portal. But now we have this fancy little portal UI that you can go ahead and use to add a container with hierarchical partition keys. If you'd like to use a specific container and add hierarchical partition keys to that existing container, that's actually not supported right now, but our documentation goes over how users can do a container copy job to get that old data onto a new container with this new feature as well. So check out our docs for that. That's all in the same link of the blog post that's on the screen right now.
Yeah, that's a good call out. Copy collection or copy container, whatever we're calling it. A new feature to allow people to move data from one collection to another, presumably with a new partition key. You can use it to enable this feature here to make it a little easier for you, like a big red easy button for copying data. That's really exciting. This feature is amazing in its capability to, one, just help with the cardinality issue, right? And the fact that if you're using a synthetic partition key, you've got to have all pieces of it to be able to do efficient reads out of Cosmos. Here, you can have some portion of it, at least from the hierarchy, from the top level down, and have at least a bounded set of partitions rather than fanning out across the whole thing. So that's in scenarios like that, you're going to have just better performance on your read path there.
Yeah, so as you can see here, like Mark said, if you query for this hierarchical partition key, we have tenant and then under tenant user ID. If we query by tenant, we'll always land into that one subset of partitions that we have our hash on. And if we query for user given tenant, this is even better. We just go to that specific tenant and then look for our users within that tenant. And then, like I said before, we also now have more than 20 GB of data for a single tenant, which was previously not able to happen. We would have to cap you at 20 GB. So like I said, to get started, you can go ahead and create a new container in the portal. Just make sure that you're on these correct SDK versions. We also now have a preview version for JavaScript users, but you have to just be on this specific version, nothing higher, nothing lower, just this one. And then for .NET and Java, it's these two or a higher version.
Fantastic. All right. Last up, serverless. Just keeps getting better. Every event we announce something new and better with serverless. 1 terabyte now. This is just amazing. Tell us more about this.
Yeah. So if you don't already know, serverless generally lets you use your account in a consumption-based manner. So you basically pay for what you're using, which is great. So we're excited to announce that basically now all of the serverless containers will now be able to store up to 1 TB of data, and that is now generally available. And previously, the limit was 50 GB of storage. So if you're currently a serverless user, there's no further action you need to take, that will automatically be able to store 1 TB by default. And this is great because now you can have more burstability and more consumption for those serverless users. So if you're wondering whether Cosmos DB is a good fit for you, but not quite sure how your workload is going to pan out, serverless might be a great option.
Yeah, this is great. So just increase of the storage. We're still at the kind of the 5,000. Oh, actually up to 20 now, I guess. Is that so? We did increase that, didn't we? With the
Yeah.
storage increase there. Okay, well, that's awesome. I know people keep asking that question, like, "Hey, I need to be able to kind of some greater compute power when I need serverless capability there." So we're just making that better and better every time. I love it. If you're not using it to do dev tests for Cosmos, you absolutely should be. Because I think it's the most economical way of doing it. And now if even in production, you've got even greater limits here. So super exciting stuff. Tara, thank you so much. It's great seeing you. And let's keep moving. Nick, how are you, sir?
I'm good, Mark. Thank you. And hello, everybody. I am going to talk about Azure Cosmos DB for Postgres. So I am a principal program manager on the team, and I'm presenting today what we recently enabled in the product, which is a pgvector extension that allows you to natively store, index, and query the embeddings. So let's talk about what exactly is that and then how you can use it. First, I wanted to start with a few key concepts before we kind of go into a demo. So vector and vector similarity are the key concepts for everything related to AI, OpenAI. So vector similarity is a method used to measure how similar two items are by representing them as vectors. And then vectors are the series of numbers. Vectors are often used to represent data points, which are each element of the vector represents a feature or an attribute of a data point. So vector similarity is commonly calculated using distance metrics. So distance is kind of another keyword here. The value of similarity metrics typically ranges between 0 and 1. So that's kind of how we measure it, with higher values indicating greater similarity between the vectors. Vector similarity is well used in various applications, as we can see more and more in the world around us, such as recommendation systems, text classifications, image recognition, and clustering. For example, in recommendation systems, vector similarity can be used to identify similar items based on the user's preferences. In text classifications, vector similarity can be used to determine the similarity between the two documents or two sentences based on their vector representations. And finally, the embeddings is a technique of evaluating the relatedness of text, images, videos, or other types of information. The evaluation permits machine learning models to efficiently identify the relationships and similarities between data and allows algorithms to identify patterns and make accurate predictions. So that's kind of the two key terminology.
Yep. Show us. Got something to show us in action here, or we got 20 minutes. Okay.
So let's kind of take a look at where we are with this kind of pgvector. So when you're working with OpenAI, basically there are a few steps that you're going to follow regardless of your data store. First, you send data to an OpenAI model, then you receive embeddings from OpenAI model, and then you need to store them in a database. So basically what we did in our product, we enabled pgvector extension that allows you to natively store, index, and query the embeddings in our product in the Postgres database. And you can run queries to measure the distance between the embeddings that we just talked about.
Yep.
And now kind of on to the demo. So let's, okay, so I am connected to Azure Cosmos DB for Postgres cluster. So that's kind of a small one node cluster here. It is running on the latest Postgres 15.3, so that's what we have in the system. And the pgvector is supported on any Postgres that we support. So as you may see, I don't have any tables yet. It's kind of an empty Postgres server. And I already have the vector that's how the PG vector is called, the literal name, enabled in my system. So why don't I start creating the tables? So what I'm doing here, I'm creating a very simple table, which is called TBL vector with the 2 columns. One is ID, and it's going to be my primary key, and another one I'm calling embedding. So now that's kind of the vector type is the one that the PG vector extension is enabling. In this case, I'm creating the vector with the 3 dimensions. So the dimensions that we talked about, it is up to kind of the application to define how many dimensions are actually needed. So now I have the table. Let's check it. Here's kind of the table. All good. Now let's insert some sample data into this table, just so that we have something to play with. So what I'm having here are the vector values. Because the 3-dimensional values, I have kind of 3 values for each vector, and vector is in a square bracket. So I'm inserting 1, 2, 3, 5 of them. So let's take a look. Exactly 5. Oh, life is good. Now let's just run some queries and see what we have. So first, let's see if we can do something like this. So everything looks like a typical SQL query, right? So we select everything from the table where, and now this kind of small kind of character after embedding, it is the distance. So we're basically asking to retrieve all of the embeddings that have distance less than 5 from 3, 1, 2. So all of that, and kind of we're getting the response. Now we can do something that is a little bit more complicated. For instance, we can run this query and we can see the distance. For instance, we have, again, 3, 1, 2, and we would like to see how far in terms of the vector distance are the embeddings are. Yeah, so we're getting them ordered by distance. So we have all of them because I didn't limit the output. And then here is how you kind of do the querying of the embeddings in a Postgres database. And as I mentioned, you can also now natively index, so you can store index and then query the embeddings.
Yeah, this is really cool. Love this stuff, and I've been spending a massive amount of time working with this these vectors and embeddings technology with OpenAI and all of our database services there. I got a question from a user. Does this work like SoundX function in SQL Server? I actually had to go and quickly look that up. I've never heard of that function before. But basically, I guess it takes and evaluates it as the sound in a 4-character thing for the similarity. So it's, I guess, similar in that you're, I guess, creating some kind of representation or proxy for it based upon the sound of it, and then comparing that. But I think the answer is maybe.
Yeah, answer is maybe, because I'm not familiar with the SoundX function in SQL Server. Based on the description, yeah, it sounds similar.
Yeah, I mean, you're generating an array of vectors, these numbers, and then doing this nearest neighbor search on these things. So I guess it's similar in some respects, but it's, in other ways, it's not quite what we're thinking. All right, this is cool, and I think provides the absolute best segue to the last person that we've got for this roundup, and that's you, Gal. How are you?
I'm doing great. It's awesome to be here, and that was a great segue because it covered half of my stuff already. So I don't put that entire intro about what
did you steal all your thunder, Gal? Is that what happened?
No, I'm happy about it.
Okay.
Make my life easier.
Yeah. So tell us a little bit more. I don't want to steal any of your thunder, but what is the closer for us here for this build? Yeah,
so at build for Azure Cosmos DB for MongoDB vCore, we introduced vector indexing and vector search. So just like Nick explained, you take these embeddings, you store them in your MongoDB documents, and you can find, with vector search, you can find similar documents to each other based on the distance. And one thing I want to mention about this is that that's really cool is in the past, you had to use different solutions to actually do the vector search and store the vector embeddings. Now you can do the whole thing within one database, which just makes your life easier as a developer.
Yeah. So if you're using Mongo, you can, I mean, bring all your Mongo to us, kind of, right? I mean, now you can do vector search on any Mongo data you've got, and take advantage of this and go and build applications that integrate with that and all the Azure OpenAI stuff within there.
Yeah. With other MongoDB services, you have to use a different solution for your for your vectors. In Cosmos DB for MongoDB vCore, you can do the whole thing within the same database. And that also applies to OpenAI embeddings, which is what we see our customers often doing, is that they take their OpenAI embeddings and they just store them within their Cosmos DB for MongoDB vCore databases, which is pretty cool to do.
Yep.
And maybe this is a good time to just share a demo because I feel like we already covered what embeddings are. Just one thing to touch on is that as you expect with Cosmos DB for MongoDB, everything is done with the native MongoDB tooling. So you don't have to install anything in order to get this to work. You just launch an Azure Cosmos DB for MongoDB vCore database cluster, and then you can get started like right away with that. Let me go back here. Okay. How about I share a quick demo of how this works?
Yep.
Cool.
Yeah, let's check it out.
So I just have this pre-recorded. You can see over here I'm using Mongo Shell. I'm actually creating a vector index on a field called myVector. And what this does is that it creates a vector index on the documents that I have within this collection. And then I can insert documents into this collection and populate that vector field with vectors. And that's exactly what I'm doing right here. So you can see I'm inserting 3 documents, and under the myVector key, I have the value being the vector that I'm inserting. One thing you'll notice in this insertion is that the dimensions, the numbers in the vectors differ between them, which is incorrect. And that's why you see over here, when I try to insert these 3 documents, one of them is 2 and the rest is 3 numbers. This was defined when I created my vector index. I said it has to be 3. So it's rejecting that insertion because of that and only inserted the first 2 documents. So what I'm going to do here in the video is I'm going to correct that mistake. And as soon as I do that, the insertion will succeed. So right now you see there's only 2 because it only succeeded with 2 documents that had the correct dimensions, which is verified when documents are being inserted. So now I'm inserting the document that didn't make it, but I'm actually putting in the correct vector with the correct dimensions, which is 3 in this case. Now you can see that all the documents have been inserted into the database. And after that, I can actually run a vector search and see, based on this query vector that I have right here, the 0.52, 0.28, 0.12, I can see which documents in my database match that as close as possible. And right here, I do the vector search, and I want to return the top 2 results. And as soon as I do that, I get the top 2 results from my database. I can apply to recommendation systems, to similar songs, to fraud detection. So many different use cases for this, which is really exciting.
Yeah, there certainly are, and this is great. I actually followed you at Build this year and showed a little demo. This is it right here. This is a vector search and AI assistant for Cosmos DB. I spent probably a month building this thing. Actually, like dedicated an entire month of my life. Put up a little link here. You can go and check this out. You can go and git clone this thing, but this is essentially the implementation here. There's 2 versions. There's a Redis version, which we'll quickly go over, but actually we're going to quickly avoid. But there's a Mongo version in here too. That's essentially what he just showed. So in this one here, it's a little different. We use a NoSQL database, load some data in there, and then we're using change feeds from there to actually generate the vectors. It all gets stored in Mongo vCore, and then you do all of your search from there, and then you can build basically your RAG pattern applications from that. It's using a little front end right here that I wrote a few months ago. Just a very simple kind of chat GPT type interface. Shows you the prompts and the completions and the tokens that are used in there. Best of all, this thing is just one-click deploy. Make sure you go get your subscriptions whitelisted for Azure OpenAI. You can one-click deploy this thing. It will set up everything for you. You basically touch nothing, and then go hit the website, and then you can go and just run this thing in there. You can even play around with it or monitor it when you're loading up all your data. You can see all the functions getting generated. You can even show. There's a little thing in here. I created a little HTTP trigger to add a product. So you can show kind of the addition of data at runtime in there as well. And then, of course, if you want, you can remove it in there. So just taking the great stuff you guys did and then just applying it to a real world scenario like, hey, I want to go build a retail website that shows how I can do this vector search on product data and customers and sales orders and anything. Basically, anything you've got, you can vectorize that stuff and then do this type of search on for your applications. So I hope people enjoy that and check it out, use it, play around with all the great stuff we've got that's come out here at Build. And here, I'll bring all my friends back here. You folks, it was great having you on. What a great build we had this year. I'm so excited. We're kind of bringing people back to doing these in-person events again. I don't know about you, but I'm kind of sick of just the virtual only in there. So what do you all say? You say, yeah, no more virtual only. A hybrid was good, by the way. I think that's actually a nice, not everybody can attend or fly to Seattle and go to Build. So I think hybrid's good, but it was nice seeing people in person again. Rodrigo, you were there with me, Nick, Gaul. It was
being person. It's like virtual DJing. Virtual DJing is as much fun as the real thing in person. So,
oh, really? I don't know much about DJing. Virtual DJing.
Virtual DJing for people on Teams isn't as fun as having the crowd in front of you.
So just basically, spin and decks in a room by yourself. Not very exciting, but doing so in front of a room full of folks. I get it, right? You get that excitement. You get pumped up when you got people getting all crazy for you. So. Well, let's hope we got Ignite coming up, I guess, in September. And we're going to have more great stuff for you. I promise you. I won't share it with you now because I don't like making news on my show. But when we do have Ignite rolling around, I can guarantee we'll have a whole bunch of us back on here and we'll share everything that we talked about at Ignite that comes up. What is it? It's June now. So July. So I guess about 3 months, right? September something. Okay. Hey, folks, thank you very much for joining us. We hope you got a lot out of this. We hope we were able to get you caught up on all the great stuff coming out for Cosmos DB. Get everything a try. We've got previews and gated previews and live demos and everything up. Go, please, download and try it and tell us what you think. We really love to hear back from you. So that's it for us this week, folks. Thank you, everyone on the team, for joining me. It was great to see you all. And thank you, everyone, for joining us. We'll see you all next time.
Thanks.